Alright guys, welcome to your third lesson for our linear unit. This session will be covering solving linear equations. Right, so solving linear equations. Now, before we get into it, I'd like to remind you of a couple of things that we would have learned in the previous lesson that would be useful in this lesson. So if you haven't already, please go ahead and watch chapter 1a, 1b. We did not do 1c, so 1a and 1b. But just a couple of things that will help us with solving linear equations. So the first thing that I'll remind you guys of is putting like terms together. Okay, putting like terms together. It's going to be important because you will come across equations where like terms haven't been put together. So you might have something like 3x plus 2x plus 0. So let's make that 10, sorry. And in this case, 3x and 2x are like terms. So that means when you put these things together, so 3x and 2x, that's the same as adding the coefficients, 3 plus 2. We get 5x plus 10. Similarly, we might have something like 3x squared plus 2x plus 6x squared. Okay, in this case, my like terms are determined by whether the variables and the indices of those variables are the same. So if you have a look at the first term here, 3x squared and 6x squared are like terms, but 2x is not a like term with 3x squared or 6x squared because that x does not have an indice or a power of 2. So when you put them all together, you get these two, 3x squared plus 6x squared, which equals 9x squared. And you're left with that plus 2x. Okay, and it's the same for minus or minusing variables as well. Okay, the terms. Okay, so those the variables with those indices have to be the same, and it doesn't matter whether you have something like this or 9yx squared. These guys are like terms, okay, because whether the y is in the front or in the back, as long as the x has a power of 2, okay, and the y has a power of 1, they're like terms. Okay, so that's the first thing. Second thing that you guys will need to remember from the previous chapters would be expanding your brackets. Okay, expanding brackets. And what that refers to is when you have a bracket or a variable or a number on the outside, and there's brackets and there's numbers inside. So for example, 2, then you might have like 3x plus 4. To expand this bracket, okay, you need to multiply the number on the outside with the numbers on the inside. So that's going to be 2 times the 3x, okay, and then 2 times that 4. So 2 times the 3x, well, 2 times 3 will give you 6. So you multiply the coefficients or the numbers, and then if there are any letters, you have to add them together. But you only add the indices together. In this case, this 2 does not have any letters with it, so it's just 2 times, it's 2 times x. Well, you're left with the 6x. Okay. Next one, 2 times the 4, which is pretty easy, positive 8. Okay, another example might be, I'll do 3 of these just to make sure we all get it. You might have 2a times 3a squared, and you might have minus 4b. Okay, so with this one, remember you're multiplying the term on the outside with the terms on the inside. Just remember the principles when you're multiplying terms. That's another thing that you will have to remember from the previous chapters, in chapter 1b and chapter 1a and 1b. Okay, so in this scenario, okay, so the 2a multiply the 3a squared, and then at 2a multiplied by negative 4b. So in this case, 2a times 3a squared, the coefficients must be multiplied. So 2 by 3 gives you 6. And any variable must be added, but only the indices are added. So a with a little power of 1 here times a squared will give you a to the power of 3. Okay, and the next one, 2a times 4b, but that's a negative 4b, so it's going to be minus. So 2 times 4, the coefficients multiplied will give you 8. A to the power of 1 times ab, times b. Well, you can't actually put them together because it's different variables, so you're left with a, b. Okay, let's do one more example to really help you guys understand this. The next one will be, let's go with negative 2 a times, let's go negative 4b, take away, let's go 7a to the power of 4. Okay, let's confuse you guys a bit just to make sure we get it. Okay, so negative 2a times negative 4b minus 7a to the power of 4. So remember again, you're multiplying that term on the outside, okay, with the term on the inside. So in this case, it's negative 2a times negative 4b. We'll start with that. Now, when you do that, remember the negatives. When you multiply two negatives together, it becomes a positive. So negative 2 times negative 4 will give you a positive 8. A and B cannot be added together, so we leave them as just A and B. Easy. Next one, you've got the 2a, negative 2a with the negative 7a to the power of 4. So the coefficients multiplied together, negative 7 times negative 2 times the negative 7 will give you a positive answer. So 2 times 7 is 14. And remember, when you multiply the variables, indices have to get added. So there's a little 1 up here. A to the power of 1 times a to the power of 4 will give you a to the power of 5. Okay, and there is your expanded answer. Okay, the third thing that we will need to know for solving linear equations, okay, is finding or solving unknown variables. Okay, so a variable, remember, is a letter. Okay, and the idea behind what you'll actually be doing in this chapter, as it says here, is solving or finding your unknown variables. Okay, so let's say, for example, you might have an equation that looks like this. 2 plus x equals 7. Okay, in this case, you'll have to find out what this variable is. Okay, this x. Now, in order to do that, you're also trying to isolate or make it by itself. Okay, so that's the idea behind solving these unknown variables. Now, you obviously can look at it and say 2 plus 5 equals 7. But there is an actual method. Instead of just guessing what x is going to be, there is a method to it. But the idea, this idea here, is trying to figure out what that unknown variable is. And now the method that I am referring to when it comes to finding or solving unknown variables is, I guess, connected to the fourth point that I have now, which is your inverse operations. So these are the 4 things that we'll need to know when it comes to solving equations, solving inverse operations. So just to quickly recap, you need to know how to put like terms together. We need to know how to expand brackets. We need to know how to find, solve unknown variables, which we'll be doing now. And the last one will be inverse operations. Now, really quickly, you've actually done this in your previous units. So we did this in geometry and trig, I believe. Okay, where you had the inverse operation. So inverse operations are basically when you have the opposite of your operator. So these guys, your plus or your positive, your negative, you multiply and divide. These are what you call your operators. Now, in an equation, okay, you'll either be adding, subtracting, multiplying, or dividing terms. And the idea behind these is you have to understand what is the opposite of them. Okay, so when you have a addition, the opposite of that would be minus. Okay, or subtraction. So the inverse of addition is subtraction. So these are the inverses. Okay, the inverse of minus or subtraction is addition. Okay, the inverse of multiplication is division, and the inverse of division is multiplication. Okay, and we'll see how these actually work when we go through some of these examples, but I might quickly go through a few here just to show you guys how these two, so finding unknown or solving unknown variables and inverse operations work. Okay, so let's say you have a question that goes 2x, let's make it even easier, let's go 2 plus x equals 7. Okay, and you're trying to figure out, okay, what is x? So this principle here of finding the unknown or solving the unknown variables is where it'll be useful to understand what all these mean. Inverse operations, putting like terms together, and expanding brackets. So in this case for now, what you want to try and do with a question like this is isolate the x. Okay, make x by itself. And in order to do that, you need to move any number on this side over to the other side. Well, that's how I understand it. So any number on this side or any coefficients on this side need to be moved to the other side. So if I want to make x by itself, I am moving this 2 here. So that means this is a plus 2 or a positive 2. So when I move it over to the other side, instead of the inverse operation of a plus or a addition is going to be subtraction. So that 2, when I move it to the other side, becomes negative 2. So what you're left with here is x equals 7, take away 2. Okay, and you can actually easily solve that now. X minus 7, as you guys know, x equals 7 minus 2. 7 minus 2 in this case is 5. And if you wanted to test that, you can actually put 5 back into this equation, okay, and test to see if the equation actually makes sense. Okay, so 2 plus 5, because x was 5, equals 7, and that definitely makes sense. Okay, let's try another one. Let's say you have x take away 4 equals 11. Okay, what is this mystery x? So remember, the idea is you want to try and isolate, make x by itself. So if that's the case, you've got to move everything on this side of the equal sign to the other side. Now this here is a negative 4 or a minus 4. So when this is a minus 4 and you want to move it to the other side, think back to the inverse operation. So this guy leaves and you put it on the other side and it becomes plus 4. Okay, so you're left with x equals 11 plus 4. And then you can solve that. 11 plus 4 equals, we know, as 15. And if you wanted to check it, you could actually substitute that 15 into your equation and test to see if x indeed equals 15. Oops, sorry. So 15 take away 4 is definitely 11. So that means that would make sense. All right, so let's fix that up. Okay, so that's the principle behind inverse operations and also finding unknown terms, which we will use, okay, for these questions when we get to them in these examples. So first and foremost, let's start and understand what is a linear equation, okay, and decide whether these are linear equations. So the criteria for a linear equation is, first and foremost, it must have, okay, an equal sign. Okay, you got to have an equal sign in your linear equation. So if your equation doesn't have an equal sign, okay, then it doesn't make sense. It's not a linear equation. Okay. And the second criteria is it cannot have indices or powers. So if any of your variables have powers, okay, it's not an equation. And the third thing to remember is it can't have square roots. Okay, you can't have square roots in your equations. Okay, you can't have square roots in your equation. So it's got to have an equal sign, no powers or indices, and no square roots. So let's have a look at these. X squared, well, there's an x squared there, so that's not an equation. Okay, here you've got square root x plus x, so there's a square root, so that can't be an equation. Okay, here you've got a indice of just 1, so there's no squares, and there is an equal sign, so it's indeed an equation. And same with this, even though you move the x over to the other side, or you try to isolate the x's, in this case that would definitely be an equation, and there's an equal sign. Okay, so here, decide whether these equations are true when x equals 2. So what you have to do in here is similar to what we were doing here. We were substituting that variable back into the equation to test if it was true. So here we're testing to see if 3x minus 1 indeed equals 5 by substituting the x with this 2 here. So if we go 3 times, remember this means 3 times x, so 3 times 2, take away 1, does that equal 5? Well, 3 by 2 is 6, minus 1 equals 5, and that definitely makes sense. 6 minus 1 equals 5, so that equation is true. Okay, let's try this one. 4 take away x, which is 2, equals 1, and that's not correct because 4 minus 2 equals 2. That's wrong. Okay, this one here, 2x plus 1 over 5 equals x plus 4. So if we change that, 2 times 2 plus 1 divided by 5 equals 2 plus 4. Okay, so in this case, you've got 2 times 2 is 4 plus 1. So let's put those in brackets. 2 times 2 is 4 plus 1 over 5 equals 2 plus 4, which is 6. Now 4 plus 1 equals 5 over the 5 equals 6, and that's incorrect because 5 over 5 equals 1, and 1 does not equal 6. So that equation does not make sense. Okay, it's incorrect. Okay, some more of these examples. Decide whether these equations are true when x equals -6. So we're going to substitute -6 into these variables. So remember, this means -3 times 6. So -3 times -6 plus 17 apparently equals -6. So let's work that out. -3 times -6. So negative and a negative make a positive, and that equals 18. Plus 17 equals -6. I can already tell this doesn't make sense. 18 plus 17 is 35 equals -6. So nope, that is an incorrect or not a true equation. Okay, let's try another one. Remember I said when you do these questions, you need to know how to expand your brackets as well. Yeah. So let's rewrite this. Remember, x will equal -6. So it's 2 times 4 minus -6 equals 20. Notice how we have two negatives here. Remember, when that happens, you have to turn it into a positive. Negative and a negative make a positive. So you're left with 2 times 4 plus 6 equals 20. And you can try and expand it first, or you can actually solve what's happening in here because these guys are already like terms. So effectively it becomes, or if you want to do it the long way, you could go 2 times 4 is 8. 2 times 6 is 12 equals 20. Okay, put these together, which they equal 20. That equals 20. So this equation makes sense, or it's true. Okay, last one. 2 minus 3x over 10 minus 12 over the x. Okay, so remember, we're just substituting the x into that -6 there. So you're left with 2 minus 3 times -6 over 10 equals -12 over -6. Okay, there's a lot of negatives happening here. And remember the principles when it comes to putting together negatives. Okay, so in this case, let's put these two together first. So you're left with 2 times, or 2 bracket, -3 times -6, okay, equals positive 18 over 10. Okay, equals -12 divided by -6. Okay, remember, negative and negative, when you put them together, even when you're multiplying or dividing, becomes a positive. So 12 divided by 6 leaves you with 2. Okay, so moving on from there, 2 times 18 is 36 over 10 equals 2. And already that will not make sense, okay, because 36 divided by 10 does not equal 2, so that's incorrect. That equation is not true. Okay. So let's do some actual solving linear equations. Solve these equations by checking your solution using substitution. So let's figure out what these unknowns are. So remember back to what I mentioned previously when we just started this lesson, was that the idea behind these questions is you want to try and make x by itself. You want to try and isolate the x. Alright, so in this case, x plus 8 equals 13. On this side of the equal sign, we need to make x by itself. So what are we moving here? We're moving that positive 8 or that plus 8. So when I move that to the other side, okay, it becomes minus 8. So you're left with x equals 13, take away 8. Alright, and then from there, 13 minus 8, solving it will equal 5. Now, if we try and substitute that back into the equation, 5 plus 8 equals 13. That makes sense, so that's correct. Next one here, x minus 5 equals 3. Again, you're trying to isolate that x, make it by itself. So in that case, if you want to make x by itself here, we're trying to get rid of this negative or this minus 5. So in that case, if it's minus on this side and you move it to the other side, it becomes plus 5. So you're left with x equals 3 plus 5. And you can solve that, you know that x equals 8. Substitute that back into your formula right there. Let me just rub this out because it is in the way. But substituting that back into the formula, change x to 8. 8 take away 5. Does that equal 3? Yes, indeed it does. Okay, 8 minus 5 equals 3. Okay. Next one, negative x plus 4 equals 7. Now this one gets a bit trickier. Okay, but remember in front of that x, just remember there's a 1 there. So this is essentially saying negative 1 times x plus 4 equals 7. Okay, now in this case, remember you're trying to isolate the x, make it by itself. In here, it's always a good idea to start with the constant or that number that it's by itself. So this is a plus 4. If I move it on the other side, it becomes minus 4. So you're left with negative x equals 7, take away 4. You solve that, okay, that equals 3. 7 minus 4 is 3. Okay, now we're not finished. You can't end with that x being a negative. Remember the x, you need to isolate it, make it by itself. So remember there's a 1 here. Okay, there's a magic 1 that we don't see here. So when I move that 1 is, remember, just a negative 1 times x. That means, okay, if that negative 1 gets moved to the other side, it's not a, don't think of it as a minus 1. It's a multiply by minus 1. So the opposite of multiply in this case, when I move it to the other side, is divided by negative 1. So you're left with x equals 3 over negative 1. Okay, and then if you simplify that, you're left with x equals negative 3. So let's substitute that back into the equation. Okay, so negative 3 plus 4 equals 7. But remember there's a negative there. So you're left with negative times negative 1, you can think of it as, and remember that x equals, that x equals a negative 3. Okay, so that means negative 3 times, negative 1, sorry, times negative 3 plus 4 equals 7. And does that make sense? Well, let's see if it works. Negative 1 times negative 3, you're left with 3 plus 4 equals 7, and that indeed makes sense. So x must be negative 3. These ones get a bit trickier, okay, but I think once you do a bit more practice with them, you will get used to it. Last one here, negative x minus 5 equals negative 9. Again, you're trying to isolate that x, make it by itself. So that means in this case, you will be moving that negative 5. Now, if it's a negative or a minus on this side, it becomes a plus on the other side. So you're left with negative x equals negative 9 plus 5. So negative x equals negative 9 plus 5 is negative 4. Okay, now we move that negative. Remember, there's a magic 1 there. Okay, get rid of that negative. It's a times. Okay, now when it's a times or a divide, the actual positive or negative value doesn't change. Okay, only when you're adding or subtracting and you move it to the other side do you actually change add to subtract, or subtract to add. But when it's times or divide, you leave that value, but you're changing multiply or you're changing it to divide. So in this case, it's multiplied by negative 1, so it becomes divided by negative 1. So you're left with x equals negative 4 over negative 1. Now if you simplify that, okay, the negatives are put together to make a positive, and this 4 divided by 1, you're just left with 4. Okay, so now if you substitute that into your formula, that negative, that 4 into this formula here, this is saying negative 1 times 4, okay, minus 5 equals negative 9. So put those in the brackets. Negative 1 times negative 4 gives you negative 4, minus 5 equals negative 9, and that is indeed correct. Negative 4 minus 5 is definitely negative 9. Okay, let's move on to the next part here. Solving these equations, and then we'll substitute the x's for the variable that we got to check if it's correct. So, alright, so the principle again behind this is you're trying to isolate and make x by itself. Okay, so let's, and remember I mentioned that you always want to start with the constant term that's on its own there. So the number by itself. This is a plus 5. If I move it to the other side, it becomes negative 5. So you're left with 4x equals 17 minus 5. Okay, solving that, 17 minus 5 is 12. Now I'm writing every step I'm doing so that you guys can see what is happening. Next, I want to try and isolate, okay, the x. So there's a 4 here. This is a 4 times x. So when I move it to the other side, it becomes divided by 4. So 12 divided by 4. So therefore x equals 12 over 4. And when you divide 12 with 4, you get 3. Okay, now substitute that back into the formula. 4 times, remember the x represents 3, and this is 4 times. So 4 times 3 plus 5 is supposedly 17. Let's solve this first. So 12 times 3, so 4 times 3 is 12, plus 5 equals 17, and that makes sense. So we are correct there. Okay, this one here, okay, a little bit trickier, but I always suggest that you try and expand the brackets first when you get a question like this. So this is 3 times 2x plus 3 times 5. So 3 times 2x, okay, start with that, and then you get 3 times 5 equals 4x. So when you try to expand these brackets, okay, 3 times 2x gives you 6x. Okay, 3 times the 5 will give you it's a positive 5, so plus 15, okay, equals 4x. All right, now you might be thinking, this one looks a little bit tricky because now you have an x on both sides. Okay, when this happens, okay, what you want to try and do is put all the x's on the same side and put all the numbers and the constants and the coefficients on the other side. So I'll repeat that again. Put all the x's on one side and put all the numbers and the coefficients on the other side. So in that case, I will try and move the shuffle the numbers around so that the x's are on the same side and the numbers are on the other side. So in this case, I'm going to start with this 15. It's a plus 15. If I put it here, it becomes minus 15. So this is what you're left with. 6x, okay, equals 4x minus 15. Okay, let's start with that. And the next thing you need to now do, okay, like I said, put all the letters on the same side. So you see here, you've got a 4x on this side. I want to move it to the other side. This is considered as a positive 4. Okay, this is a positive 4. So when I move it to the other side, okay, forgot to put some arrows here, so that'll go there. So when I move that 4x on the other side, it's a positive. Okay, it now becomes a negative 4x. Okay, it becomes a negative 4x. So I'll rewrite that equation. You're left with 6x, okay, minus 4x equals negative 15. Okay, now we can put some like terms together. You see that? 6x and the 4x, or the negative 4x, are actually like terms. So when you put them together, okay, you're left with 2x. Okay, because 6 minus 4 equals 2, equals negative 15. Last step, okay, is this 2 that needs to move, because remember you're trying to isolate that x. So that 2, okay, when you isolate it, it's a 2 times x. So when you move it to the other side, it becomes a divide by 2. So your final equation is x equals negative 15 over 2. Okay, now that one does get a bit tricky to put in your calculator, but if I tried to solve that, let's see if it makes sense. So apparently, our answer, when you put all the x's back in there, well, 4 times x will become 4 times whatever x is, which is negative 15 over 2. Okay, so if you put that in your calculator, let me get my calculator up. Okay, when you put that in our calculator, negative 15 divided by 2, put these in a bracket. Okay, so that's 4 times negative 15 divided by 2. It should equal negative 30. So that means in this equation, if you replace x with negative 15 over 2, you should get negative 30 as well. So, so 3 times 2 times negative 15 over 2 plus 5, okay, it should also equal negative 30. So if I put that in my equation, and my calculator, sorry, should be correct. So 3 times 2 times negative 15 divided by 2, and then plus the 5. It should equal negative 30. And that is correct. So equals negative 30. So we got that one right. Okay, that's it for this exercise. Go ahead and complete your exercises for question or chapter 1D. So we're looking at these exercises here for 1D. Thank you.